All right, guys. So just a little while ago, we talked about Thevenin and Norton equivalents in terms of linear networks. And the, the question was, if you had a large linear network, and by linear network we mean a set of electronic components that were composed of voltage sources, current sources, both independent, dependent, resistors, you could have them hooked up in a very, very complicated manner. Is there any way that we could replace that entire network with an equivalent network that was composed of simpler elements? And the answer was yes. Yes, we could. This led us to Thevenin equivalents, in which a large linear network, no matter how many components it had, was replaced with one voltage source in series with one resistor. The question really arises, hopefully in your mind, is this the only type of equivalent linear network that I can replace the larger one with? And the answer is no. There's another one that you can actually replace it with that is called the Norton equivalent network, right? So let's begin with the following. So let's transition. So let's talk about Norton equivalents. Oops. Equivalents. And the beginning point was, again, diagrammatically, we had some sort of linear network. And we had some external terminals A and B. And for a Norton equivalent, what we do is we replace this entire linear network, whatever happens to be inside of here. Keep in mind that this might be a huge circuit. We replace it with a single current source in parallel with a resistor. And this is the Norton current, and this is the Norton resistance, like this. Now, when it came to Thevenin equivalents, one of the things that we ended up doing so with Thevenin equivalents, we had considered two circuits. The first circuit that we had considered was the open circuit. And we considered this to find the open circuit voltage. And it turned out that the open circuit voltage was actually the Thevenin voltage. Similarly, we had also considered the short circuit, and this was to find the short circuit current. And we found that if we found the short circuit current, then for the Thevenin equivalent of the network, so if you had your linear network here with respect to the terminals, I'll just say this is Ln for linear network. The Thevenin equivalent network consisted of a voltage source that happens to be in series with a resistance, and this was the Thevenin resistance. And the relationship between the short circuit current and the open circuit voltage and the Thevenin resistance was such that the Thevenin voltage was the same thing as the open circuit voltage, and the Thevenin resistance was the open circuit voltage divided by the short circuit current. So all of our efforts were really geared towards finding this and finding this, right? Now, for those of you that paid attention to the source transformation lecture, right? Remember that if you happen to have a voltage source that's in series with a resistor, through a source transformation, you can actually replace it with a current source that's in parallel with the same resistor, right? And take a look at the relationship between the Thevenin equivalent and the Norton equivalent. Notice that the Thevenin equivalent itself lends itself to a source transformation. So if you actually take this network and you perform a source transformation, then the network that you will be left with, the equivalent that you will be left with, will actually be a Norton equivalent. Right? So here, through a source transformation, that network does actually turn into the Norton equivalent network. On top of that, it can also be shown and argued that if you find the open circuit voltage and the short circuit current using the same type of circuit analysis, then the short circuit current will also equal the Norton current in this network, and the Norton resistance is the same as the Thevenin resistance, which is equal to the open circuit voltage divided by the short circuit current, like this. Right? So when you're taking a look at any linear network and you actually want to simplify it as much as possible, you can either find the Thevenin equivalent network or you can find the Norton equivalent network. And you always take a look at the short circuit current and the open circuit voltage in order to construct those equivalent networks. And we'll see here in a few videos how this can be used in order to solve circuit analysis problems.